So, hello everyone and welcome to this lecture. So, in this lecture and the next few lectures, we will be covering some basic concepts of the Ethereum blockchain network, and we will also have a hands-on demonstration on how to use the Ethereum network and how to use an Ethereum network client and connect to it and then do some transactions. Okay. So, in this particular lecture, we will be covering a basic introduction of Ethereum, and then we will talk about what are the different Ethereum networks and how we can connect them using a specific Ethereum client which is called Go Ethereum client. We will also see how we can do some transactions and some queries using this Go Ethereum client. So, the keywords for this lecture are Ethereum, Go Ethereum client, which is also called GETH or GoETH, and then we will be also talking about the test nets, and we will be using those test nets to do some transactions. So, Ethereum technology is very popular now. It is the most popular cryptocurrency after Bitcoin, and it is very similar to Bitcoin in the sense that it is also a permissionless blockchain platform, but there is some key difference between Ethereum and Bitcoin. So, Ethereum technology basically lets users to send cryptocurrency to anyone for a small fee, and it also powers applications that everyone can use and no one can take down. So, this latter part is the more important feature of Ethereum, which differentiates it from Bitcoin. The development of Ethereum started around 2013 and it got finally launched in July of 2015, and from the very beginning Ethereum was designed such that it would be able to execute decentralized applications called smart contracts. So, it is basically a permissionless blockchain platform which is capable of executing smart contracts. So, a Ethereum network is of course a decentralized network. So, there is no concept of any centralized Ethereum server which handles everything. It is completely decentralized, and it is formed of computers or participating computing nodes, which are simply called as nodes that can verify blocks and Ethereum transaction data. So, what is a node? So, any computing device which is running an Ethereum client. So, Ethereum client is a program which is capable of connecting to the Ethereum network and do transaction. So, any computing node or any computing machine which can run this Ethereum client it can be called a Ethereum node. Okay. So, this diagram gives you some insight on how this Ethereum network is formed. If we consider this particular blue box, then we can say that it is a Ethereum node, and this diagram inside this blue box is basically the Ethereum client. So, this Ethereum client has many components. The most important one we can say is the POW consensus module. So, this particular consensus module is responsible for handling the consensus in the Ethereum network, which can run actually multiple algorithms. So, Ethereum supports proof of work, also proof of authority, and some other consensus protocols. But the Ethereum main network, which everybody uses and which has the cryptocurrency called Ether or Ethereum, that uses proof of work consensus. So, this proof of work consensus module is responsible for consensus, and there are some other components, namely the state, Ethereum state, which basically maintains the state of the ledger. Then there is this EVM, which is the Ethereum virtual machine, responsible for executing the smart contracts which will be deployed in the Ethereum network. Apart from that, there is the transaction pool, which is also called TX mem pool, which is a pool of transactions that are cached within the memory of the Ethereum client, and which is used for validating them and executing more transactions on top of the updated ledger. So, apart from all these components, there is another module which is the P2P module. So, this is basically the module which is responsible for communicating with the other clients, other Ethereum clients, and therefore other Ethereum nodes. So, if this blue box is one Ethereum node, then this one node will be communicating through a peer-to-peer connections with other Ethereum nodes. So, we can see here that there can be direct connection from one Ethereum node to other Ethereum nodes, and then in this way they form a peer-to-peer network, which is basically the Ethereum network. So, in the Ethereum network there is no central server, and independent nodes are connected in this P2P network, and in the Ethereum main network there are nodes participating from all over the world. So, this map is basically highlighting from which geographical regions how many participants are connecting, and this is basically a heat map indicating the from which region the number of nodes are more and from which region less number of nodes are participating. So, this Ethereum main network is actually one single instance of an Ethereum network. Since Ethereum is a permissionless distributed ledger platform, any user can start their own Ethereum node, or any group of users can start their own nodes and connect them together to form their own network. Okay. So, if I want to create a new Ethereum network, I can do so with my friends. I will start my own Ethereum node, and my friends will be starting their own Ethereum nodes, and when they connect together in this and form this peer-to-peer network, that will constitute a new Ethereum network. But here the Ethereum main network is the most popular network which everybody uses to do their transactions. Basically, this main network is supporting the Ethereum cryptocurrency. Okay. So, how do we connect to an Ethereum network, and how do we interact with this Ethereum network? So, any Ethereum network, maybe mainnet or maybe some other networks. So, in this diagram, this round circle is basically one Ethereum network, and an Ethereum network will have several components. This diagram is showing only some of them. So, it is showing accounts and smart contracts. So, the Ethereum ledger will have all transaction data, and then all accounts, their balances, and also smart contracts, states and variables, etc. So, this forms the Ethereum network. But how to connect to that? So, a user, that is me and you, can connect to an Ethereum network through a software which is called a Ethereum client or a node. Okay. So, there are several Ethereum client implementations, but the most popular one is this one, GETH, or Go implementation of the Ethereum client. And usually users do not use this Ethereum client directly to connect to the Ethereum network. Instead, developers use this Ethereum client and then use some more libraries and SDKs to develop applications which are then used by the end users. So, for developing applications on Ethereum, different SDKs such as web3.js or ether.js are used, and then those applications are used by the end users. So, the Go Ethereum client or any other implementation of the Ethereum client will be connecting to a Ethereum network, but we have to always remember that this network is not a centralized one, and there is no central point of contact. So, this actually looks like a kind of a mesh network with different nodes connected via peer-to-peer connection, and this Go Ethereum client will connect to some of them and then broadcast its own transactions or download the latest ledger state, etc. Okay. So, we will be talking about particularly one Ethereum client which is the most popular one, that is Go Ethereum or Geth. So, this is basically the official Go implementation of the Ethereum protocol, and this is also the main command line interface client which is recommended by Ethereum. So, it acts as an entry point to the Ethereum network, and we will see that we can use the same client, that is the Go Ethereum client, to connect to any Ethereum network. It may be the main network, or it may be some test network, or it may be your own network that you have started. So, the Go Ethereum client is capable of running in different modes called full node, archive node, and light node. So, we will be seeing how to switch between these modes and what are their significances also. And finally, this is very important that the Ethereum client, or this Go Ethereum client, won't be used by the end users directly. Instead, what it does is it provides a layer, and then a layer that can be used by developers to build their applications on top of it. So, using some SDKs, application developers can connect to the Ethereum client and use that to communicate with the Ethereum network. Okay. So, to support that, Ethereum client exposes JSON RPC endpoints on top of HTTP web sockets or IPC transports, and these interface, the JSON RPC endpoints, can be used by developers to ultimately build their applications. So, next we will be having a hands-on demonstration on how to use the Go Ethereum client. But before getting started on using Go Ethereum client, we have to know how to install it. So, here we are seeing the steps on how to install this Go Ethereum client on the Ubuntu operating system. So, you can go to the documentation page of Go Ethereum client and then look at the installation instructions for other platforms also, but here we will be covering everything considering the Ubuntu operating system. So, installation is simple, and it involves these simple steps. So, first you would need to add the Ethereum repository. To do that, we need to execute this one single command, and then once the repository is added, we need to install Ethereum using these two commands. We will see how. So, first we would need to add the repository for installing Ethereum. For that, the command is sudo add apt repository -y, then ppa ethereum/ethereum. Okay. So, when you hit enter, you will see that it will be adding this particular repository to your apt package manager, and then it will be also updating the sources lists. So, once this step is complete, what you need to do is you need to update the source list once to ensure that the new repository that was added in this previous step gets updated. So, the command is sudo apt get update, and this will basically pull all the sources lists and update the list of packages, and next we can install the Ethereum client, or the Go Ethereum client, using the command sudo apt get install Ethereum. So, at this point the Go Ethereum client is installed, and you can check whether it is installed properly or not using this command get version, and it will show you the version of the Ethereum client which is installed, and also some other informations. So, once you have installed the Go Ethereum client in that way, next you can get started using it. So, the first thing that you would need to access the Ethereum network is one account, of course. So, there is a simple command to see what accounts you already have or create new accounts and update them. So, the command is get space account space, then for listing the account you can hit list. For creating the new accounts you will need to type new, and for updating an account, which is basically updating the password which is related to an account, you would need to provide this command update. And then finally, if you have an account which already exists in some other system, or you had created previously somewhere and you want to import it, then you have the option to do that using import. Okay. So, each account in Go Ethereum client is password protected, and whenever you create a new account, it will ask you to provide a new password. So, once you provide that password, it will save that account in your wallet. So, Go Ethereum client will handle its own wallet, and it will keep all your accounts and their keys, basically public keys and private keys there. The private key won't be stored in clean text. Instead, for security reasons, it will be password protected by the password you are providing while creating the new account. So, we will see how we can create a new account, and also we will see how it is being saved in the wallet. So, after installing Go Ethereum, if you do get space account space list, if you it will show you the list of accounts, and you can see that there are no accounts presently. So, to create a new account, you need to type the command get space account space new. So, if you hit this command, it will ask you for a password. So, you need to provide a new password for your account. So, here we are typing a password 123, but it is not showing up in the terminal because it is kind of hidden, but it is taking the password that we are typing. So, at this point you can see that it is saying that our account key was generated, and here is the public key of the account. So, our new key was generated, and this is the public key of the account that will be used for doing transactions, and this is the path to the wallet where this account is stored. Now, one Ethereum account has two keys, one public key and a private key. So, if you want to do some transactions, you would need to use the private key to do so. But this private key is not stored in this directory directly. Instead, it is password protected. So, if we do Go account list now, you can see that we can see that there is one account 0. Okay. So, we can see the contents of the wallet that is saved by just seeing the contents of this particular file path which is being printed. So, to do that, we can use the command cat and then space, then path to the wallet file. So, this will print out the details of the account we just created, and this is the path. The path is by default in your home folder, then in a directory called .ethereum, and then a directory inside that called key store. So, here you can see that the address of the account is basically the public key which was created, and then there is a field called crypto. So, we do not find the private key of the account in plain text. Instead, the password we provided while creating the account is used to encrypt it and keep that private key securely in the wallet. So, later we will see how we will be using this account and do some transactions with it. So, we saw how to create a new account and how to list the accounts that we created, and how to get the contents of the key that is stored in the wallet. Okay. Now, we will see how to connect to a particular Ethereum network. So, starting the Go Ethereum client without any flag basically connects to the Ethereum main network. While connecting to the Ethereum main network is fine, you may want to do that, but usually to do transactions in the Ethereum network, it requires a fee, small fee called gas or transaction fee. And so, for doing transactions in the Ethereum main network, you would need to provide Ether, and that might be expensive. So, for testing purposes, we usually resort to some test networks which are available. So, you can also create your own network, but it is more convenient to do some transactions for testing purposes through these popular test networks. So, the Go Ethereum client by default recognizes the following 3 test networks, and possibly more. You can refer to the documentation to get more information, but these 3 are the most popular ones. So, the first one is Ropsten, and then the second one is Ringp, and finally Goerli. So, these 3 test networks are usually used for testing purposes, and there are some subtle differences. The Ropsten network uses proof of work consensus protocol just like the Ethereum main network. While this is fine, but this since it is proof of work consensus protocol, it is a bit slower and transactions take more time to get mined. So, the second one, the Ringp network, and also the third one, the Goerli network, uses a different consensus algorithm, which is proof of authority consensus, where basically a pool of miners handle the work of mining new blocks, and thus it is a bit faster. So, in this particular tutorial, we will be connecting to this third test network, the Goerli test network, and we will see how we can query the network and do some transactions. So, before connecting to a network, we must know in what mode we are running the Ethereum client. So, the Ethereum client can run in the following sync modes: full, fast, snap, and light. So, the full node actually downloads all the blocks including headers, transactions, and receipts, and generates the state of the blockchain incrementally by executing each block one by one. So, as you can understand, full node is basically replicating the entire ledger and also validating it entirely, and as a result, this is more the most resource heavy. So, you need a high computing and storage power to run a full node. In contrast, the fast node and snap node, or these nodes which are connecting in this fast and snap sync modes, actually downloads all the headers and also the receipts and verifies them. So, the snap mode actually uses the same steps, but with a faster algorithm, and this is the default option that you can use to connect to the Ethereum network. So, if you run the Go Ethereum client without any sync mode option specified, it will by default resort to the snap mode. But we would be using the final sync mode, which is the light mode. So, light mode actually downloads all block headers, block data, and verifies only some of them randomly. So, light node is the most lightweight, and it relies on other full nodes and other nodes to actually sync only some part of the data and verify some part of the data randomly. So, it is the fastest one that we can use to connect to the Ethereum network. So, if we run our Ethereum client with this full mode, it will take a long time to connect and sync. Whether if we run our if we run our Ethereum client in this light mode, then it will be much faster. So, to connect to a particular test network, here Goerli, we can use this simple command get space hyphen Goerli sync mode light. Okay. So, we will see how we can connect to it. So, here we see that there are a bunch of logs which are coming up. but from this first line you can read that it is starting the Go Ethereum client in the Goerli network and connecting to it to the Goerli network, and then it is writing that block synchronization has started, and it is being followed by some other logs like imported new block headers, etc. So, it will continue like this, but we are stopping this for a moment and we will connect to this network again. So, once we have connected to this Ethereum network through the Go Ethereum client, we also need to use this Go Ethereum client to do some queries and some transactions. So, to do so, the Get client or Go Ethereum client can expose two kinds of APIs. So, the first one is using JavaScript console over IPC, that is the first API which is being provided by Go Ethereum client, and the second one is using RPC over HTTP. So, IPC allows us to do more in terms of functionalities, but for using IPC API we need a direct access to the node where the Go Ethereum client is running. So, you would need to run your application program which is using Go Ethereum client in the same host system, and you cannot run the application in some other host and communicate it to the Ethereum client. So, instead what we would use is RPC over HTTP. So, this allows remote application to access the Go Ethereum client, and of course, this has some security considerations because you are opening up your Ethereum client node to remote access. So, other applications which are running remotely can access this. So, of course, it has some security considerations. So, to connect to the Goerli testnet and to enable the RPC over HTTP API, we need to add another option which is --HTTP when we run our Ethereum client. So, the command will stay same, just we would need to add one option --HTTP. So, we would be using the same command get space --Goerli, then sync mode light, and we would be adding HTTP option to just enable the RPC over HTTP API in get. So, it will be printing the exact same things, just you would notice that it is still connecting to the Goerli testnet, but here one thing that is added is it is saying HTTP server started on this endpoint 127.0.0.1 and port 8585. So, we will keep that Ethereum client running in the other tab in the terminal, and we will be using that Ethereum client and communicating with that client from another terminal. So, we would be using that Ethereum client to query the balance of a particular account. So, we can there are many queries, but this is one of the simplest one that we will be using to see how we can query something from the Ethereum network. So, to do any query using RPC over HTTP through GET, you need to do a post request to the HTTP endpoint. So, as we saw in the last step that our GET client was started and it had started an HTTP endpoint in 127.0.0.1 IP address, which is localhost, and in the port 8545. So, in this particular address we would be sending a post request which will have a JSON payload. Now, this JSON payload looks like this. So, it will have JSON RPC version which will be 2.0 almost always, and then the method would be ETH underscore get balance. So, depending on the type of the query or the type of the transaction we want to do, this method will keep on changing. Here we want to query the balance of an account, and according to that we have stated this method. So, for this particular method get balance, we need to pass this parameter which is the address of the account for which we want to know the balance, and latest. So, latest is basically specifying at what point of time or in what block level we want to know the balance for this account. So, we want to know the balance of this account which is there at the latest block. So, therefore, we are passing latest. So, to send this particular post request, here we will be using an HTTP client called curl or curl. You can use any HTTP client, but curl usually comes installed in most Linux distributions and it is pre-installed in Ubuntu. So, the command is pretty simple. We need to do curl, then pass this option post, because we are posting a data, and then we will be sending this request to localhost 8545. Instead of localhost, you could also write 127.0.0.1, which was the IP address which is specified. Next, the header, which is content type, this content type header would be set to application/JSON, because we would be posting a payload which is of type JSON. And finally, we will be passing the data which we want to post, which is the same payload we saw in the last slide. So, let us see what output do we get when we run this command. So, we can see that after doing this post request, we get this output which says the JSON RPC version, the ID that we passed, and a result which is 0x0. Now, 0x0 means that it is the balance of the account in hexadecimal format. So, here the balance is 0, but if we check the balance for some other account, then we will be able to see some other values. So, for this particular account, we see that we got a non-zero balance as output, and it is 0x29a, something like that. So, this is in hexadecimal format. Now, you can convert it to decimal to know the balance of this account as usual, or there are some commands which you can use. So, if you copy this particular hexadecimal representation and then use the command echo, then dollar symbol, and in two braces if you write 16 hash and then paste the hexadecimal value and then press enter, then this bash command will give you the output of the balance in decimal format. So, here you can see the output is 3 followed by several zeros. So, we will see what this means. Okay. So, the balance in Ethereum is usually represented in a unit which is called Wei. So, in Ethereum, the primary unit or the primary unit of the cryptocurrency is basically Ether, and Ether has many other units. So, 1 Ether is actually 10 to the power 18 Wei, which is the smallest unit which is used in this Ethereum network. So, from this particular table you can see that the smallest unit is Wei, and then there are several others like K Wei, G Wei, and then milli ether and micro ether, like that. So, you have to count how many zeros are followed after this Wei. So, because the balance is represented in Wei, if you do 10 to the power minus 18, then you will be able to find what is the balance in the unit which is ether. So, in conclusion, in this lecture we saw how we can connect to an Ethereum network, but before that we learned what is an Ethereum network and how an Ethereum network is formed of peer to peer connected nodes. So, we saw that it is a completely decentralized permission platform, and we can use an Ethereum client, specifically the Go Ethereum client, to connect to this network and do some queries. We saw that we can use RPC over HTTP API to communicate with the Go Ethereum client and then query the balance of some accounts. So, thank you, and in the next lecture we will see how we can execute some more complex transactions over the Ethereum network.